Okay, good evening, everyone. I'm just gonna give it another minute or so before we start the webinar, just to make sure that everyone gets a chance to log in. Hopefully, you guys are all safe in this weather. Welcome to EdCo's Exploring Science. Anyway, my name is Rochelle. I'm just gonna wait another minute there, and then we'll start. All right. Welcome, everyone. Welcome to Exploring Science. I'm so grateful to be joined by two of our co-authors of Exploring Science, Michael Callahan and Dr. Lisa Shine, this evening. We're going to be talking about the new features of Exploring Science now in its third edition and how to prepare for junior cycle science exams. So this webinar is being recorded. So if, for example, you miss part of it, or if you want to share it with your colleagues, we will be sending out a link after this, 2 days after this. And if you have any questions, feel free to pop them into the Q&A box, and we will address them later. If you want to begin, Michael.
Okay. Good evening, everybody, and thank you very much for your attendance. I am aware that there's a rugby match later on tonight. Some of you might not be interested, some might, so I'll be fairly brief. I just want to talk briefly about the Exploring Science and the new edition that's coming out. EDCO over the last 2 years or so have carried out extensive research in dealing with teachers, and their reps have been feeding back information about what people felt good, bad, or indifferent. And the main features of the new book, just to go through them pretty quickly now, the main features of the new series of books is that we used to have 3 books, we now have 4. The new book being the experiment book. The details were tied in to the textbook. Teachers didn't feel that was good. So now we have a textbook, an experiment book, an activity book. And very importantly, because we're told that a lot of teachers aren't aware that it exists or they have it in a cupboard, there's a teacher resource book, which has a huge amount of information and which answers a lot of the questions that we're sometimes asked at webinars like this, and people aren't aware that the answers are sometimes to their questions are in the teacher's resource book. So it's a sequence or a series of 4 books. The main features. Obviously, content will alter slightly in textbooks as we go along to include exam material that was asked in the exam papers of 2019, well, in the sample paper, first of all, and in the exams of 2019, 2022, 23, 24, and 25. So we've had to tweak things slightly here and there to bring in material that we thought was relevant. We were very conscious of the fact that it's a common level specification. So our language, we've been trying to be careful that it's relevant to, the higher levels and to the common level specification, the ordinary level specification, let's say. As a couple of people have pointed out, a number of questions from the EDCO book have appeared in the previous exams. There have been several cases of that, so that kind of tells us that we're not far away. We're on the money, and there have been several examples of that. We have a new author on the Earth and Space, due to personal circumstances from the previous author that they're not available anymore. And some of the new content in the Earth and Space chapter, very briefly, there's new comparisons in space to cover the ES3 learning outcome. There's increased emphasis on model making as a means to visualize concepts in the Earth and space section. There's new experiments in Earth and Space to develop students' investigative skills, so we have new experiments in there. And there's more reading comprehension questions to allow students to evaluate media-based arguments. These are in everywhere else in the book, but there's a little bit more of them now brought into the Earth and Space section. Lisa Shine, that we'll talk to in a few minutes, has been involved in the Earth and Space section of the book. Students right throughout the book, our idea was students were encouraged to convert their skills to knowledge via independent learning, that as much as possible it's independent learning for themselves as they go along. At the start of the book, as an intro in the textbook, there's new guidance on the drawing and interpreting graphs. There's been a lot of graphs asked recently in Junior Cert and, of course, in Leaving Certs as well. So we thought it was only relevant to bring in more material there to help the students as they start off the transition into second level education. There's many opportunities throughout the various books for peer-based learning where they talk about each other and how they got on and discuss things like that. And therefore, obviously, there for formative feedback opportunities to learn as they go along and what are they learning and comparisons with each other, etc. in that way. Each chapter in the textbook now has summary questions, which we would have had before, and obviously then more and more previous exam questions. As the exams have gone on, there's more and more scope to put in an exam question here, there, elsewhere. And where possible, we've fed the exam questions in along with the revision questions, if you want to call them, or summary questions. There's additional content in most chapters. This wasn't in the previous books. Some of it was. Did you know comments are very extensive to promote discussion and ideas and chat about things. Every chapter now, I think every chapter anyway, has exam tips, 1 or 2 exam tips relevant to that particular chapter. Every chapter now has YouTube links relevant again to the chapter. Reasonably short, I think under 4 or 5 minutes maximum YouTube links. And we also now have chapter summaries. Every chapter now has a chapter summary, which is very useful for revision, which Lisa might talk about now in a few minutes. As regards the students themselves and the student book, there's a huge volume, an absolutely huge volume of digital material online. This material would include things such as, sorry, Lisa, obviously PowerPoint presentations, which the teachers can use as well. There's experimental videos. There's diagram animations and activity videos, interactive quizzes and assessment questions. And there's quite a lot of digital material, which is there in the background to help anybody who needs it. In the activity book, there's guidance. Obviously, we couldn't bring this out too much before, but now much more guidance now for students undertaking their CBA and how they might go about it and that type of thing. There's reading comprehension style questions are included throughout the activity book, as they are some in the textbook, but you can't put too many of those into the textbook because it gets too big. So we put as many of those as possible also into the activity book, and many of them are modeled on previous exam questions and exam material like that. And then, of course, for the students, there's a separate experimental book where they don't have to carry their textbook into the lab and be filling in details into a textbook. That was just unwieldy and difficult. So there is now this separate experiment book. As regards the teachers resource book, it has the solutions to all the questions throughout. All those answers are there. They're in that book. There's an overview of the junior cycle, some of the theoretical overview, and the overview includes the 8 principles, the 24 statements of learning, and the 8 key skills within the framework. There's an overview of the Junior Cert Science specification. It's good to have all this material in one place, because sometimes if an inspector is coming in, somebody's going for inspection, you can't find documents. You're double checking, am I up to speed on this? What's the layout there? It's all now included in this book. And there's guides then to assessment in Junior Cert Science as well in the teacher book. And there's guides to how to use Exploring Science, particularly in the case of planning for Junior Cert Science, including schemes of work and units of learning and how to learn them out, how much time to devote to them and all that type of thing. Now, that's a very brief overview of what's new to the books. I'll hand you over now to Dr. Lisa Shine, who's going to talk to you about another matter altogether. Thank you.
Okay, thanks, Michael. I'm going to talk to you about using the Exploring Science package for preparing your students for exams, because ultimately, I suppose that's where we're all aiming towards. So some of the features that I'm going to talk about, Michael has briefly mentioned, but I'm going to show you lots of examples in the book and how they match up with the type of questions that are being asked in the exams. Because I suppose where we start when we're preparing and our students are preparing for exams is with the Junior Cycle Science learning outcomes here that we're all familiar with. I suppose we very closely follow these learning outcomes. The learning intentions are listed at the start of each chapter in our textbook. So you'll find at the start of every single chapter that you open in our textbook a list of the learning intentions. And as you look at each chapter, they're very closely linked to the Junior Cycle Science learning outcomes. So you can see here, this is the chapter on reproduction. And if you look at the learning outcome that we're given as teachers, you can see that almost the wording even follows very closely what's in the Junior Cycle Science learning outcome. So we have these set of learning outcomes, and this is, I suppose, what the start of each chapter in the textbook looks like. You've the learning intentions at the start of the chapter. They align very closely with the Junior Cycle learning outcomes. We also have a set of keywords at the start of each chapter, which you could use in a lot of different ways in your classroom, especially preparing for exams. We've put a lot of thought into these keywords. They're the words that your students will come across in the exam that they'll need to know for the exam. So it's a handy little revision tool there for them at the start of each chapter. As you know, the poster with the learning outcomes on it is very brief. So we get a lot of, we've spent a lot of time looking at past exam paper questions when writing this book, just to give us even more guidance towards what exactly is being looked for when students are going into exams. Um, uh, and then the other useful tool as well, not only do they have the learning intentions and the keywords at the start of the chapter, but as Michael said, a new feature is that there's a chapter summary at the end of every chapter. So, as science teachers, it's great to teach your students about all sorts of interesting things in science, and, really develop their investigative skills, let them do research projects, find out interesting things. But usually coming up towards this time of year, in third year anyway, as they're heading into mocks and into their junior cycle exam, your students will be coming to you saying, but what do I actually need to know for the exam? That was great that we did a research project on XYZ, but what do I need to sit down and learn for the exam? And that's where you can direct them to the chapter summary, which appears at the end of each chapter. It's kind of the bare bones kind of skeleton of, the material that they need to know, and that'll set them up for going into the exam. So the types of questions asked on the junior cycle exam you'll be familiar with. I'm going to just list them here, and then I'm going to show you how we deal with each of these question types when you're, to help you prepare your students to manage them. So you'll come across these multiple choice tick box questions, these close questions, the fill in the blanks. There's obviously lots of calculations. Students may have to draw diagrams or label diagrams. There's lots of data analysis. Graphing is guaranteed to come up in the exam for students pretty much. Experimental practical questions and applying scientific principles to real world scenarios. So these are, I suppose, kind of the main types of questions that come up, and reading comprehension style as well that Michael mentioned we've put more emphasis on as well. So I'm going to just work my way through them and show you that by following our Exploring Science package, your students should feel prepared to tackle any of these questions that come up in the exam. So we'll start with the multiple choice tick box type of questions. So it's this type of question where a student is given maybe a definition, like the definition of it's a solar system there, a star and all the objects that orbit it, and the student has to tick the right answer. There's less of an emphasis now on students learning off definitions and regurgitating them, but they do still need to be familiar with lots of definitions in order to be able to answer questions like this. In our textbook, these definitions are highlighted in colour in bold, so that the students can easily find them throughout the textbook. So there you can see we have the definition of a solar system in our textbook, which would allow the students to answer that question. And then part B in that junior cycle exam question, a system of billions of stars is a galaxy. Again, you can see in the section in that chapter in our book, under the heading of galaxies, we have the definition in bold, and then the extra material and the extra information not in bold underneath it. So I think it's really useful for students that you can guide them and say, in terms of definitions that you need to know, they're the things that are in bold in the textbook. Go back to the textbook, find everything in bold. You can go and write it out onto your record cards or do whatever your students like doing. Again, just to show you a few more examples of how that's presented in the book, for resistance, density, enzymes, you can see that the definitions that students need to be familiar with are highlighted very well in bold there, that they'll be easily able to find while they're preparing for and revising for exams. And so then the fill in the blanks type of question, again, this tends to come up every year on the exam. This was last year's exam where students are given a number of words and they have to slot them into a little section of text. Again, in our book, we've tried to give lots of examples of these throughout all of the chapters in the book, where students, just like the style that's asked in the junior cycle exam, they're given the words, they're given the text, and they have to slot them in. So here you can see one in the photosynthesis chapter. Here you can see one in the chapter on solids, liquids, and gases. And then this is one from our digestive system chapter. These appear throughout the textbook and student activity book so that your students will be familiar with this type of question and well able for it going into the exam. In terms of calculations, there are always going to be several calculations on the exam. They appear like this. So here's last year's exam. This is your area and volume chapter. Students are asked to calculate the surface area there of object B. Or here's another one where they're asked to calculate the weight of the football, and an emphasis is placed on units in the exam as well. And we have placed a similar emphasis on our questions. Any chapters that involve calculations, we've given lots of practice, because I know with my students, if there's only one practice question for them of a particular type, it's not enough for them to really get a handle on those calculations. They need lots of practice and they need to be doing lots of it. So any chapters where you see calculations, there'll be lots of calculations at the end of the textbook chapter, and there'll be lots more in the student activity book, which is great for differentiating as well, especially for your stronger students. You could give the whole class the textbook chapter questions to do, and then the speedier ones can move on to their activity book if needs be. For the weaker students, maybe, a lot of the calculations in our book are scaffolded. I know calculations can be an area that some students find particularly tricky. You can see a question here on voltage, current, resistance, and you can see how it's scaffolded. They're presented with the formula and they can fill in the blanks there. It's just a little bit more scaffolded than some of the other questions, and just makes it a little bit more accessible for weaker students. And this is a layout of a question that you could easily see on the junior cycle exam as well. And again, in relation to voltage, current, resistance, there's loads of practice here, different numbers, but the same method repeated, which really helps them to get a grasp on their calculations. Diagram drawing and labeling. Again, they're going to be drawing something in their exam and they're going to be labeling something in their exam. So here you can see it could be in relation to an experiment. You can see in the 2024 exam, they were asked to draw a labeled diagram of an experimental setup for a separation technique. In 2024, they were asked to label parts of the reproductive system. And in 2023, they're drawing arrows on the diagram to show the direction of blood flow. And they've previously been asked to label parts of the heart as well. So again, we've put lots of this type of practice into our book. So this is a question from our student activity book, very similar to what has come up in the past on the junior cycle exam, where they're presented with a diagram of the heart, with lettered parts of the heart, and they have to label that in the experiment book. Data analysis, huge emphasis on this in the junior cycle exam, where students will be presented with data that they haven't seen before and asked to analyze it. One that seems to come up a lot, is where students are presented with a graph like this, showing the effect of exercise on heart rate. And then they're asked to answer questions. You can see some of the questions there on the graph. So they need to be familiar. Your junior cycle students aren't going to be able to go into an exam and answer that unless they've had lots of practice looking at graphs and maybe creating their own graphs and that kind of thing. So again, the student activity book is where a lot of our questions to do with analysing data and graphs come up. So I'm just going to show you some of those. In the distance, speed, time kind of section, graphs seem to have come up a lot in the past on the junior cycle paper. And I know students do find it tricky matching this graph that they see on the page with actually what's going on with the car and its movement. So again, lots of practice is key here. If they only see this question once and they only get one chance to practice it, they're not going to have a good handle on managing these graphs. So you'll see in this distance, speed, time section, which I've zoned in on here in the activity book, There's loads of examples. This is just a second one there, motion of a car. This again, motion of a cyclist, just slightly different graph, and then questions that students have to answer. And by giving lots of examples of these graphs, the students can really become comfortable with that type of question, which seems to be almost guaranteed to come up every year on the exam. And just while I'm mentioning the student activity book, I'm just going to draw your attention to the first question that comes up in each chapter in the the student activity book. And question 1 always relates to the keywords that were at the start of the textbook chapter. And so again, as I said, these are keywords that are likely to come up in the exam that students will need to be familiar with, that they need to understand. And they can get practice with these keywords in the activity book, where they have to write a short sentence using each keyword there. So you could use that either in class, or it's a handy one for revision. You could leave it when you're covering the topic, and then when you come back to revise the topic in third year, let's have a look at the keywords in the activity book. Let's see, can we put them into sentences? Can we remember what they are? So they feature at the start of every chapter in the student activity book. You can see them there again for the photosynthesis chapter. It's the same for all of the chapters. The keywords that appear at the start of the textbook also feature there at the start of each chapter in the activity book. And then I'm just going to show you some more pages from the student activity book. In terms of data analysis, we've put lots of opportunities for students to analyze lots of different types of data. So on the left here, you have a page out of the rates of reaction section. On the right, you have a page out of the photosynthesis section. You can see these questions that we've put into the student activity book really look like the questions that come up in the exam. Students are presented with graphs that they have to interpret. They're presented with diagrams that they have to comment on. And they might be presented, as in the photosynthesis section there, with data that somebody else has generated. And then they have to comment on that data or use it in some way or draw a graph with it. But we've really made a big effort with the student activity book to present students with questions that are going to be similar to what they see in the exam, so that they'll feel comfortable and prepared going into the exam. I've mentioned graphing there, but just, I suppose, to show you a little bit more about how that appears. Graphs come up every year in the exam. This was the 2024 exam. Quite commonly, students will be presented with data like they are here. They'll be given the graph paper and asked to draw a graph and probably go on and comment and answer certain questions on it. And we've loads of opportunities for students to graph results throughout the book. Anywhere where there's an experiment or a question where a graph is possible, we've tried to put it in, because there's a huge emphasis on graphing in the junior cycle exam these days. And the more practice students can get with graphing and with making good graphs, the better. So for example, this is a new experiment in the Earth and Space chapter. Earth and Space, I suppose, has traditionally been one where there hasn't been a huge number of experiments. But I've really made an effort to try and include more activities there to make it more engaging for students. So this is an experiment where students are investigating how the height of a ball affects the diameter of its impact crater. And it relates to, to meteorites and, that kind of thing in the Earth and Space chapter. So students are dropping a ball, measuring the size of the impact crater, and they're comparing the height to the size of the crater. And this is somewhere where I said, okay, we could get them to record the results, but even better, we can get them to graph the results. Because in the exam, they're going to have to draw at least one graph, just looking back over recent years. So we've really tried to put in as many graphing opportunities for them as possible throughout the experiment book anyway, but also in the student activity book. And then while I'm on the experiment book, this is kind of the layout of each of the chapters or each of the experiments in the experiment book. And you can see, again, the questions are very closely aligned to the type of questions that are asked in the exam. So here you can see they're asked, what hypothesis did they make? In the exam, they're very commonly asked, what hypothesis could you write for this experiment here? My students anyway find it difficult writing hypotheses. They're going to have to write a hypothesis every time they do an experiment in this book, so they will get comfortable with it. We've quite a question on how reliable and fair it is, because that comes up a lot in exams. Safety, obviously. Controls, they're frequently asked about controls in exams, so we have that in for our experiments. And then variables, dependent, independent, fixed variables, again, comes up frequently in the exam, so we have it here in the experiment book. We've tried to cover all of the types of things that they could be asked. We generally get them to label diagrams because they frequently have to draw and label diagrams in the exam. They have their little reflection there, which you can see on the right-hand side here, to think about their work. Might help you as a teacher to pinpoint where their strengths and weaknesses are. And then there's generally questions that specifically relate to the specific experiment that they're working on. So all of our experiments in that experiment book follow a similar kind of layout. Here again is just another example of where students in our student activity book are practicing graphing. This again could be a question straight out of the junior cycle exam, where this is in the electricity chapter, they're presented with data that another student has generated, and then they're asked to graph voltage versus current, just to get them practicing their graphing technique. Experimental practical questions, there's always going to be a question in the exam on experimental work, more than one question. This is last year, this is the respiration experiment, and you can see there's a lot going on here where they're asked to graph results, they're asked to comment on the setup there, why is it important that flasks don't allow heat in or out? They're asked, what would the student conclude from the results? So there's a lot for the student to think about in this type of question that commonly comes up. We've tried to replicate those type of questions in our package in the textbook, activity book, and experiment book. So here you can see a rates of reaction experiment. Not only are the students being asked basic recall questions like name the two reactants, but they're also being asked the type of questions that require deeper thinking, like why is cotton wool placed in the neck of the flask? How could you increase the rate of reaction? These kind of deeper thinking questions are the ones that are going to come up for them in the exam. This here is a photosynthesis experiment question. Again, they're given data, they get to practice graphing. And again, this is a question from our student activity book. They're asked the type of questions that they're going to be faced in the exam. There's a mixture of basic recall, testing, do they know what independent, dependent variables are, what's the main gas in the bubbles, basic recall, but deeper thinking, why is pondweed used in this investigation rather than land-based plant? Why should the light source be kept at the same distance from the equipment throughout the experiment? We're getting them developing that kind of deeper thinking about their experiments and their scientific method throughout all of these type of practice questions. And again, there's loads of these for them to work through. So they're developing lots of skills by answering a question like this. And again, this is just another one from our rates of reaction chapter. You can see, again, it looks really like the type of question they get in the exam where they're analysing a graph and analysing the data that comes up on the graph. And there's more questions that I'm showing here that, touch on that kind of deeper thinking, as well as the more basic recall questions as well. Applying scientific principles to real world scenarios is also big on the junior cycle exam. So the type of thing that would come up here, like in this 2025 exam, would be where students are presented with data or scenarios that they have maybe never seen in class before, but they're being asked to use the knowledge that they've learnt and the skills that they've learnt during the course and apply that to this scenario that they haven't come across before. So here they're being asked, what's the relationship between global temperatures and the variety of life on Earth? They may not have covered that specific question in class, but they're using the knowledge that they have done in class and applying it to this new image or whatever that they're seeing. And again, we've tried to do this, give them practice with this throughout the book. and that they learn that it's not just learning material off by heart and putting it down in the exam. They are going to have to use their brains and to think deeply about some of the questions. So this is in the digestive system chapter. They're not just going to be asked to label a diagram of the digestive system or to define what an enzyme is. They're going to have to think a little bit more. And this is a question from the textbook, where they have to think, why do each of the following groups need more food? Younger people versus older, males versus females, active versus inactive, and so on. Just getting that deeper thinking, I suppose. And we've really tried to again thread this throughout all of the chapters. So this is from the chemistry, acids and bases chapter, where they're not just saying what pH is an acid, what pH is a base. They're really thinking deeper. Okay, you've got a dentist. They're giving you advice on waiting an hour after a meal before you wash your teeth, using a straw when drinking fizzy drinks. Why is your dentist getting you to do these things? Think about the scientific knowledge that you've learnt in class and apply it to this scenario relating to a dentist that you haven't talked about in class. You'll also see the little blue and green icon up in the top left-hand corner there is the kind of think, pair, share icon. It kind of means group work. So we have also put an emphasis on group work as well, so that students can pair up and discuss these type of trickier, deeper questions with a partner. So to encourage kind of group work or working in pairs in your classroom. The last kind of type of question then that I'm going to touch on are the reading comprehensions. These come up a lot on the junior cycle paper. This is just an example out of our textbook where this was, I think, in the climate change chapter. There is a big paragraph here which I wasn't able to fit onto the one screen, but we've used real world articles. So this one is from Met Éireann. The link is there. There was a big article about temperature changes and temperature highs and lows and all of that. The students have to read it and then answer the questions just like they would in the junior cycle exam. But we've tried to really make it as applied to the real world as possible because one of the learning outcomes in the nature of science, it says that students need to be able to analyze media-based arguments and, media-based articles. They'll have lots of practice of that in the textbook. So they're kind of the main type of questions that crop up in the junior cycle. And I hope I've shown you that we've covered all of them very comprehensively throughout our package. And to finish off, I just want to mention a little bit more about the new chapter that we have, which is chapter 38, Comparisons in Space, which I've written into the new book. The reason I put this into the new book was because I spent the last few years teaching comparisons in space. It is its own learning outcome on the Learning Outcomes poster, but most of the material out there doesn't explicitly teach it. It kind of comes up incidentally throughout other Earth and Space chapters. I kind of feel that it warrants its own chapter because it is its own learning outcome in the learning outcomes that we've been given. So I've put it together really just because, like, as you can see in 2025, students, there is an emphasis on comparisons in space in the exam. Like, this is what students were presented with last year, a table with lots of data in it, with lots of words like mass, diameter, volume, density, temperature, distance from the sun. There's a lot going on in a table like this. And the more practice students can get with big data tables like this that relate to space, the better. And I just didn't feel like there was enough out there for me to be able to do enough practice with my students. So in this chapter, I've kind of covered what I find my students struggle with when they're faced with a question like this. If I just go back, you'll see, say, in terms of volume and mass, the figures in the exam are given in scientific notation. And students, a lot over the years in our science department anyway, we haven't explicitly taught scientific notation. We've kind of assumed that they've covered it in maths. I do think it needs to be explicitly covered because it comes up so often in this comparisons in space question. So I've put in little tips and practice bits for students to be able to convert scientific notation to decimal numbers that they might understand a bit better, really to help them so that when they're asked which has a greater density, Jupiter or Earth, they can work out which number in scientific notation is bigger or smaller, because they do struggle with that. So there's loads of practice in this chapter for them with scientific notation, because as you can see, there's the 2024 paper. The mass of the Earth and Venus there is given to them in scientific notation. So all of the students in your class need to be very comfortable working with this before they approach this type of question. The rest of this chapter, I've really just approached very methodically with the learning outcome in mind. So the learning outcome says that students should be able to interpret data to compare Earth with other planets and moons in the solar system with respect to, and there's 4 properties here: mass, gravity, size, and composition. And I've literally gone through each of them in the chapter so that students get lots of practice with each one. So here you can see a sample question where they're asked to compare the masses of the different planets. So I introduced them to the idea of mass, and then they get lots of practice comparing masses in space. Density isn't specifically mentioned in the learning outcome. It does come up in the exams though, and it is something that's in those comparison charts or those comparison tables in the exam. So it's important, I think, to get its own section in this chapter. They're given the definition of density, and then they're given lots of practice comparing different planets and moons and their densities. Gravity and size are kind of linked, because generally the greater the size of the object, the greater the gravity. So again, I've introduced the students to the idea of gravity, what units that are used for size, and lots of practice questions where they can compare gravity and size of different celestial objects. And then composition is the last bit that's mentioned in that learning outcome there. Again, like that's a tricky word for lots of junior cycle students. So I've explicitly gone through what does composition mean, especially in relation to space science. And again, given them lots of practice, like this practice question here, which you can see is actually a group work question as well, where they're going to be given the composition of different planets, different moons, different celestial objects, and asked to compare them. Because in the exam, they are given data not only on the planets in the solar system, but on other celestial objects like moons that are called Titan, Europa, and Io. So you want to, I suppose you don't want them to get a fright when they see the word Titan when they come into the exam. So in my chapter, I've tried to include the names of lots of the most common kind of celestial objects in our solar system, that they'll be familiar with them going into the exam. So I suppose to summarize, as Michael said, we've got the 3 books for the students. We've got the new experiment book, we've got our textbook, we've got our activity book, and then the teacher resource book with lots of help there for teachers. In the textbook, just so that you can see a quick view of some of the chapters, we've got our biological world, we've got our chemical world. You can see some of the chapter headings there, very closely aligned to the learning outcomes so that the students are covering exactly what they need to know going into the exam. Physical world then, and Earth and space, again, very closely following the learning outcomes, very closely following what's going to come up in the exam. And then really importantly, we have a chapter on nature of science. This is, the data interpretation skills, the drawing diagrams, drawing graphs. We have a whole chapter that you can kind of dip into with your students to make sure that their skills in terms of nature of science and scientific method are good. So we feel like we've prepared a package based on, I suppose, what we've seen coming up in the exams over the last few years, the type of skills and knowledge that students will need to approach this exam confidently, and hopefully it's a package that your students will enjoy using.
Thank you so much, Dr. Lisa, for that comprehensive overview. And also, Michael, very, very grateful for your time tonight. If there are any questions, just feel free to pop them into the Q&A box. There are 2 questions here that were asked. If you guys can address them. There's a question here. Are there videos of experiments? Michael, Lisa, yes, I'll answer that. There are videos of the experiments. There's another question here. Have you taken steps to ensure the book is accessible to a mixed ability class?
Absolutely, yes, I would say to that. I taught in a deaf school for 40, nearly 40, almost 40 years. And I'm always conscious of, the level that some students are at a higher or a lower level. And it's one of the features that we went through, that we're all the time looking at the level of the language used. And even in the questions, then there are some, the questions tend to start easier, and then medium questions, and then more thought-provoking questions as you go through. So we are conscious. It's one of the points I made at the start of it's a common level paper. So you have to cover all levels, let's say. So yes, we've done that. I would say
Yeah,
definitely.
I showed there as well. Like a lot of our questions, we have scaffolded for weaker students. So yeah, I think we've covered the broad range of students that would appear in your classroom. Definitely, it should be accessible to all, and we've made a big effort with the language that it would be.
Perfect. Thank you for that. If there are no other questions, I'm just going to let people know. I'm going to pop the email where you can request your CPD certificate of attendance. Here, I'm just going to put it down. And you should be able to share your, what do you call this? Email me your certificate of attendance. And yeah, hold on a second. Let me see. There's a question here. I am a newly qualified teacher. I'm in my second year since graduating. Is there any way in which it can be accessed or a physical copy posted? Okay, right. Roisin, yes, you should be able to get a physical copy. So if you request a copy, a sample copy via Edco, so it's info@edcolearning.ie. And you should be able to get a sample copy for when you are made permanent in your school. Okay. Okay, I'm just conscious of the time as well, because I know that okay, thanks, Roisin. If you have any more questions, please feel free to email us at info@edcolearning.ie. And yeah, thank you again for your time this evening. Thanks, Michael, and thanks, Dr. Lisa, and thanks everyone for your time. Good evening.
Thank you. Good night.
Thank you. Bye bye.
Thank you. Bye bye.